In chapter number 3, the world of numbers, we will discuss exercise set 3.4. Let's begin with first question. Represent rational numbers 2 by 3, negative 5 by 4 and 1 by 2 on a single number line. We have discussed how to represent rational numbers on a number line, but here we have to represent all these three numbers on a single number line. So in my previous class I said you we want that equivalent rational number concept to represent such rational numbers on number line. So here we are making these three rational numbers denominator into 12 because their LCM is 12. To represent given three rational numbers on number line, LCM of 3, 4 and 2 which is 12. Then I can write 2 by 3 as 2 into 4, 3 into 4, that is 8 by 12. Negative 5 by 4 as negative 15 by 12 by multiplying in numerator and denominator by 3. And 1 by 2, this is mixed fraction. After converted, we got improper fraction 3 by 2. So 3 by 2 can be written as 18 by 12 by multiplying numerator and denominator by 6. Now we have these three equivalent fractions of respect to three rational numbers. Here denominator is same, so we can represent now all these three numbers on a number line. Here we have to divide unit interval into 12 parts because 12 is in denominator. So therefore we are doing so. Let's come to here 0, 2 by 12, 4 by 12, 6 by 12, 8 by 12, 10 by 12 and 12 by 12, that is 1. Then 14 by 12, 16 by 12, 18 by 12, 20 by 12. Same on left side of 0, that is all the negative numbers. If you observe here, I am taking one unit as a 2. Now to represent 8 by 12, we have to check on right side. So here our 8 by 12. So 18 by 12, this is also positive number. So 18 by 12 is here. Now it remains to represent negative 15 by 12. So we have to check on left side. 2, 4, 6, 8, minus 10, minus 12 by 12, that is 1, negative 1, minus 14 by 12, minus 16 by 12. Now as the unit length I choose as a 2 unit. So 15 minus 15 by 12, this number has to be in between negative 16 by 12 and negative 14 by 12. So here is the number negative 15 upon 12. So here is the location for negative 15 by 12. Now we can write this number line as this. So here we just wrote number in our actual whatever given number. So here 2 by 3 means 8 by 12. So here instead of 8 by 12 I wrote here 2 by 3. Instead of 1.5 I wrote here 3 by 2, and instead of negative 15 by 12 here I wrote negative 5 by 4. 5 by 4. Next question number 2. Find three distinct rational numbers that strictly lie between negative 1 by 2 and 1 by 4. We have to find three distinct rational numbers between these two rational numbers. So we have discussed the density theorem that for any two rational numbers a and b, there always exists a number a plus b by 2, where a and b are distinct rational numbers. The method, that is density theorem, this is known as average method also. There are two methods to find rational numbers between two rational numbers. So first method, that is average method or density theorem. So average method means we have to find out average of these two numbers. So first number we are going to find negative 1 by 2 plus 1 by 4 upon 2, which is equal to LCM of 2 and 4 is 4. So this is negative 2 by 4 plus 1 by 4 upon 2. Negative 2 plus 1, that is negative 1 upon 4 upon 2. Now here 4 into 2, 8. So which is equal to negative 1 by 8. Therefore, we got a number negative 1 by 8 which lies in between negative 1 by 2 and 1 by 4. Now next we are going to find a number between this interval. Now we have two interval, negative 1 by 2 and negative 1 by 8, and second one negative 1 by 8 and 1 by 4. So we'll choose this interval and we'll find average of these two numbers to get rational number between these two numbers. Then negative 1 by 8 plus 1 by 4 upon 2. Now LCM of 4 and 8 is 8, which is equal to negative 1 by 8 plus this 1 by 4 becomes 2 by 8 upon 2. 2 minus 1, 1 upon 8 upon 2. Now 8 into 2, 16. So which is equal to 1 by 16. We got this number negative 1 by 8 less than 1 by 16 less than 1 by 4. So this is second inequality we got. Now for third number we'll choose this interval. So average of these two rational number is here 1 by 16 plus 1 by 4 upon 2, which is equal to 1 by 16 plus 4 by 16, as the LCM of 4 and 16 is 16. So 4 plus 1, 5, 5 by 16 upon 2, 16 into 2, 32. So 5 upon 32. Therefore, negative 1 by 2 less than negative 1 by 8 less than 1 by 16 less than 5 by 32 and 1 by 4. So in between 1 by 16 and 1 by 4 we got 5 by 32. So here we got our three rational numbers lies between negative 1 by 2 and 1 by 4, that are negative 1 by 8, 1 by 16 and 5 by 32. Now for finding rational numbers, you can choose this interval also, you can choose this interval also, doesn't matter. Next we'll discuss second method to find the same. Method 2, making denominator equal. Make denominator of negative 1 by 2 and 1 by 4 to 8. After converting this rational numbers with denominator 8, we got new numbers. Multiply this number, rational number, by 4. So we get minus 1 into 4, minus 4, and 2 into 4, 8. So minus 4 by 8. Similarly here, 2 by 8. We can easily find out rational numbers between negative 4 by 8 and 2 by 8, that are negative 4 by 8 less than negative 3 by 8 less than negative 2 by 8 less than negative 1 by 8 less than 0 less than 1 by 8 less than 2 by 8. Hence the rational numbers between negative 1 by 2 and 1 by 4 are negative 3 by 8, negative 2 by 8, and so on 1 by 8. So this is a method. Now question should arises here, why should I choose a denominator as 2? Why not 2? Why not 4? Because if I choose here 4, then what will happen? It becomes minus 2 by 4 and 1 by 4. So here we'll get only this number 1 by 4 and 0 in this fashion. But we want three rational numbers, that's why I make denominator 8. Don't consider that I did here 2 into 4. Okay. So accordingly, number of rational numbers we have to find, we have to convert denominator. Question number 3. Simplify the expression negative 1 by 4 plus 5 by 12. To add these two rational number, we should know denominator must be same. To make this denominator equal, we will find LCM of 4 and 12, which is 12. So multiplying to negative 1 by 4 by 3 in both numerator and denominator. So we get negative 1 by 4 plus 5 by 12 is equal to negative 3 by 12 plus 5 by 12. Now denominator is same, which is equal to minus 3 plus 5 by 12. Minus 3 plus 5, 2 upon 12. 2 by 12, 2 ones are 2, 2 6 are 12, which is equal to 1 by 6. Question number 4. A tailor has 15 and 3 by 4 meters of fine silk. If making one kurta requires 2 and 1 by 4 meters of silk, exactly how many kurtas can he make? So we have to find here number of kurtas that a tailor can make in the total available silk. that is 15 and 3 by 4. So let's have a solution. Total fine silk available is equal to 15 and 3 by 4, which is equal to, after converting into improper fraction, we got 63 by 4 meter. This is a total available silk. Required silk for one kurta, that is 2 and 1 by 4, which is equal to 9 by 4 meter. So to find number of kurtas tailor can be made in this total available silk, we have to divide total fine silk available upon required silk for one kurta. So this is equal to 63 upon 4 divided by 9 by 4, which is equal to 63 by 4. Division become multiplication and reciprocal of 9 by 4 is 4 by 9. Now 4 will get cancelled. 9 ones are 9 and 9 sevens are 63. So answer is 7. Hence, tailor can make exactly 7 kurtas in 15 whole 3 by 4 meters of fine silk. Next, question number 5. Find three rational numbers between 3.1415 and 3.1416. If you see these two numbers, it looks like they are consecutive, but they are not consecutive numbers. Why? Because there are so many rational numbers in between these two numbers. The three rational numbers between 3.1415 and 3.1416 are 3.14151, 3.14152, 3.14153. These are the three numbers. Let's visualize on number line. Look here, this is our given number and this is also our given number. So in between them, these many numbers: 3.14151, 3.14152, and so on, 3.14159. After 14159, we will get, after adding 1 here, if you see, everywhere we are adding 0 1, means here 1, here 2, 3, 4, 5, 6, 7, 8, 9. If we add in this one, so we'll get again 3.1416. That number will get. So these many numbers are there in between 3.1415 and 3.1416. So we have to choose any three among them. So first three we took here: 3.14151, 3.14152, 3.14153. These are the three rational numbers between 3.1415 and 3.1416. Now one can find out rational number between these two numbers, or any two number, these two numbers. Okay. Here also we can have 9 numbers like this. We can visualize this. If you zoom, if you magnify this, again you will get same number line with 9. So in that, in this here, which 9 numbers we can show? 3.141511, 3.141512, and so on, 3.141519. Next, question number 6. Can you think other ways to find a rational number between any two rational numbers? We already discussed two methods in question number 2, so we can refer that question's answer for this question number 6. This question is star. It means it belongs to HOTS and not in point view of exam.